Over the past few decades, Turkey has proven itself as a country capable of emerging from the shadow of foreign dependence in the defense sector. Despite facing both explicit and implicit embargoes from Western countries, Ankara has remained capable of developing domestic solutions focused on engine technology for various military platforms. Self-reliance in the engine sector is seen as a key factor in achieving defense autonomy. Engineering is the heart of every system, be it land, air, sea, or missile vehicles. Without reliable and independent engines, a country will always be under political pressure from foreign suppliers. The Turkish Presidency of Defense Industries has prepared various strategic roadmaps. Among them are the gas turbine engine roadmap, the power pack roadmap for land vehicles, and the National Marine Diesel Engine roadmap. All strategies are geared toward achieving full self-sufficiency. Through these roadmaps, Turkey focuses not only on procuring ready-to-use engines, but also on developing core technologies, long-term research, and cross-sector integration that will enable all platforms to complement each other. Within the engine development project, one of the main goals is to end Turkey's dependence on imports. This dependence often becomes a tool of geopolitical pressure, especially when tensions arise with allies or supplier countries. SSB President Hala Gorgan emphasized the importance of the domestic engine project. According to him, the successful integration of the engine into a domestically manufactured platform will strengthen Turkey's bargaining power on the international stage and strengthen the national defense industry. One concrete achievement is the integration of the TUMA engine, successfully installed in the Vuran and Kirpi tactical vehicles, two important platforms used by the Turkish army. The Vuran and Kirpi are multi-purpose armored vehicles widely used in military operations. With the inclusion of the domestically manufactured TUMA engine, these vehicles are now fully self-sufficient in terms of power packs and no longer dependent on foreign engines. Furthermore, the development of the Azra Gen 2 engine is specifically for tank transporters and heavy logistics vehicles, two crucial elements in supporting troop movement in the theater of operations. In the tracked vehicle sector, Turkey is developing the Aksungur engine intended for a new generation of combat vehicles that require higher thrust. Simultaneously, the Batu engine is also being developed specifically for the Altay tank. This tank is Turkey's next-generation main battle tank, which was delayed due to a German engine embargo. With the completion of testing of the Batu and Aksungur engines, Turkey is now more confident in launching mass production of the Altay, with the engine transmission also being continuously tested to ensure reliability in various battlefield conditions. Turkey's efforts are not limited to land vehicles. In the air, various domestic engines are also starting to power both unmanned and manned platforms. The PD200 engine, for example, is now officially used to power the Bayraktar TB3. This UAV is one of Turkey's mainstays in modern air operations, including from the light aircraft carrier TCG Anadolu. In addition to the PD200, the PD170 engine has been integrated into the Anka and Aksungur UAVs, both platforms used in long-range reconnaissance missions and prolonged military operations. In the helicopter sector, Turkey is introducing the TS-1000 400 turboshaft engine, designed for use in the Gökbey helicopter, a new generation of multipurpose helicopter. Certification testing of the TS-1000 400 is underway, and the results indicate readiness for mass production. This is a significant milestone, as Turkey previously relied heavily on foreign engines for its helicopter program. Progress in the missile sector has also achieved significant progress. The KTJ 3200 jet engine is now used in the Atmaca and some cruise missiles, two of Turkey's strategic weapon systems. With mastery of missile engines, Turkey now has full production capabilities, from the airframe and guidance system to the propulsion system. In the maritime realm, Turkey has also shown significant progress. The Levant engine has been successfully integrated into the Marlin Sida, an armed, unmanned ship. Furthermore, the Marin X7 engine is used on the Ulak Sida, demonstrating Turkey's commitment to mastering unmanned ship technology. Furthermore, the Mavi Batu solution for the Milcom vessels was successfully tested, thus making Turkish-made warships fully self-sufficient in terms of engines. Successes on land, air, sea, and missiles were complemented by efforts to develop advanced jet engines. The TF6000 turbofan engine, for example, designed specifically for the Anka combat UAV. The TF6000 has been successfully tested, marking a major step forward in mastering turbofan technology. This engine will support the long-range combat missions of a new generation of UAVs. Furthermore, development of the TF10000 is ongoing. This engine is expected to be the primary propulsion unit for the Kizilelma combat UAV, which is touted as one of the most advanced unmanned combat aircraft. Turkey's most ambitious project is the TF35000, the main engine to be installed on the Kaan 5th-generation fighter jet. The TF35000 is designed to deliver thrust comparable to the world's most advanced fighter engines. If successful, Turkey will become one of the few countries with world-class fighter jet engine technology. All of these achievements demonstrate that Turkey is now on the right track to achieving full self-sufficiency in defense engine technology. This self-sufficiency is not only crucial for domestic needs, but also opens up significant export opportunities for Turkey. A domestically produced engine could become a leading product that attracts the interest of many countries. The same applies to the Altay tank with its Batu engine. Turkey can export this tank without worrying about restrictions from foreign suppliers. Turkey's success also demonstrates that embargoes can actually drive self-reliance. Every obstacle faced is addressed through domestic research and innovation. The German embargo on the Altay engine, for example, ultimately led to the birth of the Batu engine. Without it, Turkey might have remained dependent on imports. This success also demonstrates the synergy between the government, industry, and research institutions in Turkey, all working toward a common vision. Political leadership also play a crucial role, with the full support of President Erdogan and high-ranking officials ensuring the sustainability of this program. Now, every major sector of Turkey's defense, land, sea, air, and missile, has a reliable domestic solution. Turkey's self-reliance in defense engineering is clear evidence that with strategy, innovation, and national determination, a country can overcome external obstacles and emerge as a respected global power.